Hello students, I am Sachitrakar. Welcome to Cars Physics. We are continuing moving charge and magnetism and this is lecture number 5 on the chapter. In previous lectures we have discussed motion of a charged particle in uniform magnetic field. And as we have discussed, it is found from experiment that when a charge moves in a magnetic field, then it experiences a force. And also it is found that the force is perpendicular to both the direction of velocity of charged particle and direction of magnetic field. Okay, and we have discussed different aspects and the effect also. Okay, then force experienced by the charged particle in vector form, it is given as Q into V cross B, which shows that the force experienced by the charged particle is perpendicular to both velocity and magnetic field. And magnetic force, this is also called as magnetic force. Magnitude of magnetic force is Q V B sin theta. Cross product of V and V is VB sin theta, magnitude of cross product. So magnitude of force is Q VB sin theta. Okay. Then case number 1, if the charge particle moves, if the charge moves either parallel or anti-parallel to the direction of magnetic field. So theta is angle between velocity of charged particle and magnetic field. If the charged particle moves either parallel or anti-parallel to the direction of magnetic field, means here the value of theta is either 0 degree or 180 degree. If the charged particle moves parallel, then angle is 0 degree. If charged particle moves anti-parallel to the direction of magnetic field, then angle is 180 degree. And in that case, magnetic force is 0. Sin 0 degree 0. And sin 180 is also 0. So magnitude of force is 0. So if force is 0, then acceleration is 0, means velocity is constant. So if a charged particle moves either parallel or anti-parallel to the direction of magnetic field, then force experienced by the charged particle is 0 and velocity of charged particle is constant. Means the charged particle exhibits uniform motion in the magnetic field. If velocity is 0, then speed, velocity is constant, acceleration is 0, velocity is constant. If velocity is constant, magnitude of velocity is speed, so speed is constant as well as direction of motion is constant. So velocity we may define. Speed in a given direction is called as velocity. If velocity is constant, then speed and direction both remain constant, means here nature of trajectory is a straight line. Means the charged particle moves along a straight line. This was case 1. Then case 2. We have also discussed case 2. Case 2. If the charged particle moves perpendicular to the direction of magnetic field. I am writing B in magnetic field. If the charged particle moves perpendicular to the direction of magnetic field, means here theta is 90 degree, and magnitude of magnetic force is QVB. Sin 90 is 1 and this force is maximum. So if the charged particle moves either parallel or anti-parallel to the direction of magnetic field, then force is 0 or magnitude of force is minimum. If the charged particle moves perpendicular to the magnetic field, then magnitude of force is maximum. And also, as we have discussed, this magnetic force is perpendicular to velocity also. If force is perpendicular to velocity, this is direction of velocity, and force acts at an angle 90 degree, then there is no component of force along the direction of velocity or opposite to the direction of velocity. So if there is no component of force along or opposite to the direction of velocity of charged particle, then magnitude of velocity doesn't change. If force were parallel, means along the direction of velocity, magnitude of velocity would increase. If force were opposite to the direction of velocity, then magnitude of velocity would decrease. But here, force has no component either along or opposite to the direction of velocity. So here, magnitude of velocity doesn't change, means speed remains constant. Since force is perpendicular to the direction of velocity, it only goes on changing the direction of velocity. Means, as we have discussed in just previous lecture, the path is a circle, and here magnetic force provides necessary centripetal force at this position. This is direction of velocity and this is direction of force. Force is perpendicular to velocity. So here speed remains constant. So the path is circular, and overall we may say the charged particle exhibits uniform circular motion. And in previous lecture we have discussed about charge of motion of charged particle in circular path, and we have found different formulae. Means what is radius of circular path, what is time period, what is frequency, what is kinetic energy, what is speed, what is angular speed, and so on. We have discussed all these, and we have done some numericals also in just previous lecture. And today is the third case, case 3. Case 3. This is third case. If the charged particle moves in a magnetic field at any angle, but we have discussed theta is 0 degree, theta is 180 degree, and theta is 90 degree. In this case, theta is not equals to 0 degree, theta is not equals to 180 degree, or theta is not equals to 90 degree. Means at any angle except 0, 180 and 90 degree. Okay, any angle we may select 30 degree, 45 degree, 60 degree, whatever be the angle. Then what is the nature of trajectory and what are the different concepts? So, as we have found, as it is found from experiment, if a charged particle moves in a magnetic field at any angle, then here nature of trajectory is helix. Means the charged particle executes motion in helical path. Like this. Helical path. Okay, we'll see it how the path becomes helical and what are the concepts behind it. Okay, Can I erase it now? Okay. If a charged particle moves at any angle to the magnetic field, let's consider magnetic field is acting or established along x-axis, and there is a uniform magnetic field is established along x-axis, okay, and a charged particle is projected into the magnetic field. See, the whole space or region, there is uniform magnetic field, and direction of magnetic field is along positive x-axis, and this is a charged particle plus q is projected along this direction, means this is velocity of charged particle, and angle between velocity of charged particle and magnetic field v is theta. Okay, now we can resolve this velocity into two perpendicular, means two rectangular components. We can resolve this velocity into two mutually perpendicular directions, and the components are called as rectangular components, as you know. So component of velocity along the direction of magnetic field is v cos theta, and component of velocity perpendicular to the direction of magnetic field is v sin theta. Okay, so this velocity is resolved into two rectangular component. Okay, so v cos theta and magnetic field are parallel to each other. So as we know, if velocity is parallel to magnetic field, then force is zero, magnetic force is zero. So due to this velocity, due to the component of v cos theta, magnetic force experienced by the charged particle is zero. Thus, if charged particle experiences no force, then this velocity will remain constant. So v cos theta remains constant. So v cos theta, the component of velocity along the direction of magnetic field, v cos theta tends to move. V cos theta tends to move the charged particle along the direction of magnetic field B. Since there is since angle between v cos theta and magnetic field is 0 degrees, so force experienced by charged particle due to v cos theta is 0. So if force is 0, acceleration is 0, means velocity is constant. So v cos theta tends to move the charged particle along a straight line, means along the direction of magnetic field. Then about another component of velocity, v sin theta. V sin theta is perpendicular to magnetic field, as we have discussed. If charged particle moves perpendicular to the direction of magnetic field, then force is maximum. So force due to v sin theta. See, angle between v sin theta and magnetic field is 90. So here magnetic force is q. In place of velocity v sin theta, q v into angle between v sin theta and magnetic field is 90 degree. So here magnetic force is q v sin theta. Okay, and as we have discussed, if the charged particle moves perpendicular to the direction of magnetic field, then the nature of trajectory is circular. Here, due to v sin theta, nature of trajectory of the charged particle will be circular, and this force will provide necessary centripetal force. And as we know, in general, magnetic force is given as q into v cross b. So direction of force is perpendicular to v and b, means direction of magnetic force is along the direction of magnetic force is along the direction of v cross b. But here V is V sin theta and V is magnetic field along x-axis. Let V sin theta is along y-axis. Then what should be direction of cross product of V sin theta cross? What should be direction of V sin theta and B, so that we can determine direction of magnetic force along the direction of cross product of V sin theta and B. See, V sin theta along y-axis of what? B magnetic field along y-axis. Simply use cross product rules to find direction of cross product. Of course, there are rules. Fleming's left hand rule, Fleming's right hand rule. We'll discuss it in later stage and we'll apply it in later stage. Here in simpler way, direction of cross product of V sin theta and B. Angle between them is 90 degree. V sin theta and this is B. V sin theta and B. As per right hand thumb rule, V sin theta and B, direction of force is inverse. So V sin theta is perpendicular to magnetic field and force experienced by charge particle due to V sin theta is inverse, and this is magnitude of force. Force is inverse, and as we know, this force will provide necessary centripetal force. See, this is inward direction, force is in inward direction, so this will provide necessary centripetal force, but centripetal force is directed along the radius towards the center, so this force is directed towards center. Obviously, this force is along z-axis. We may say here along negative z-axis. So circle will be, see, if this is x-axis, this is y-axis, and this is positive z-axis, then the circular path will be on. See, this is centripetal force. This will be circular. This will be circle. Okay. So, this magnetic force provides centripetal force and tends. This magnetic force tends to rotate the charge particle. And motion means circular motion will be in this order and it will go on rotating, okay, in different circular orbits, and the circular path will be on the plane of y and z. See, force is along z-axis and this is y-axis. This will be the plane of circle. The plane of circle will be on YZ plane. Okay. And we have discussed direction of force is towards along negative z-axis. So the plane is y and negative z-axis plane. So accordingly, this will be circular motion. Okay. Positive z-axis, negative z-axis. So force is along negative z-axis, centripetal force. Obviously, it will rotate the charge particle in circular orbit. So this magnetic force tends to rotate the charge continuously. So due to V sin theta, the charge particle will experience a force which will rotate the charge particle. Due to V cos theta, it will move along a straight line along the direction of magnetic field. So the combined motion, I am erasing all these. The combined motion, see, this is the direction of magnetic field, this is the direction of velocity of charge particle q, and this is angle theta. Okay, this component is V cos theta. It will tend to move along a straight line. Due to the component V sin theta, it will rotate in circular orbits. So the combined motion means linear motion and rotational motion will give nature of trajectory helical. Okay, as magnetic field, direction of magnetic field is axis Direction of magnetic field is axis C. This is direction of centripetal force. V sin theta cross V. This is direction of centripetal force, and it will go on rotating. Centripetal force, rotation. Centripetal force, rotation. Centripetal force, rotation. Okay. So now very simple. The force experienced by charged particle due to V sin theta, Q V sin theta into B, Q V V, again sin 90 is 1. This force provides centripetal force. This force or magnetic force provides centripetal force, and magnetic force is Q V B sin theta. And centripetal force is mv square by r, but here v is v sin theta, due to which it experiences magnetic force v sin theta, and this is v, this is sin theta, which cancels the square of v sin theta, or I am writing in this form q into v sin theta into v. Then v sin theta cancels the square form, then a radius of the circular path will be mv sin theta by qv. Just only difference, while considering the charged particle moves perpendicular to the direction of magnetic field, the radius were mv by qv. Here, due to this component mv sin theta, v sin theta, the charged particle experiences a force, the radius is equal to, thus radius is equal to, in place of mv by qv, here mv sin theta by qv. Okay. Then about time period. Time period. As we know, time period is time taken for one complete revolution, and the charged particle continuously experiences circular path, means this is helical motion. So time taken for one complete revolution, t is equal to 2 pi r. If we consider radius of circle is r, then total distance is 2 pi r. Then time is equal to distance upon speed. Distance is 2 pi r, and speed is here. Speed is v sin theta. Again, time period is 2 pi. We have got the expression for radius. Radius is equal to mv sin theta by qv. In place of radius, mv sin theta by qv divided by v sin theta. V sin theta get cancelled, and finally we may take time period is equal to 2 pi. Time period is equal to 2 pi. V sin theta is cancelled, 2 pi m divided by qv. See, while considering circular motion of a charged particle, the time period was also 2 pi m by qv. Time period is same. Okay, and final form pitch. What is pitch? Pitch is, it is distance traveled, it is linear distance traveled in one complete rotation, or you may say pitch is defined as linear distance traveled by a charged particle during one complete time period. Okay, during one complete rotation or during one complete time period. See, linear distance, the charged particle executes helical motion and linear motion along the direction of magnetic field, and along the direction of magnetic field, component of velocity is v cos theta, which is constant, which is uniform. If speed is uniform, then linear distance is equal to speed into time. Linear distance is equal to speed into time, and for linear motion, the component of velocity responsible is v cos theta. the speed p is equal to speed is v cos theta, time is t, v cos theta into t, and finally we may take v cos theta. Time period, we have found time period 2 pi m divided by qb, and solving we may write p is equal to 2 pi m v cos theta divided by qb. If you remember the formula, you can directly put this formula to get your answer. Okay, this is all about helical motion. Let's have some one or two easy numericals. Okay, just remember the formula. Question number 1. A beam of proton moving with velocity 4 into 10 to the power 5 meter per second enters in a magnetic field at an angle 30 degree. Okay, if strength of magnetic field is 0.3 Tesla. If strength of magnetic field is 0.3 Tesla and mass of proton, you know it, mass of proton, if mass of proton is 1.67 into 10 to the power minus 27 kg. Okay, we'll find different forms. It may be asked find time period, it may be asked find pitch, whatever may be. Okay, this is your question, and we'll find, we have to find first radius. You know what is radius? Radius is equal to mv sin theta by qv. Then mass of proton 1.67 into 10 to the power minus 27 kg, and speed is 4 into 10 to the power 5 into sin theta, means sin enters at an angle 30 degree. Okay, 30 degree sin 30 divided by charge of proton 1.6 into 10 to the power minus 19, and strength of magnetic field is 0.2, and as we know sin 30, in place of sin 30 we may use 1 by 2, and solving it you will get radius means the circular orbits, it rotates as well as moves in a straight line. Path is helical because angle is 30 degree, not 0, not 180, not 90. So the answer of radius will come 1.2 into 10 to the power minus 2 meter. Okay, then time period formula doesn't change, then time period is 2 pi m by qb. Accordingly, putting all the values, mass of proton m, charge of proton 1.6 into 10 to the power minus 19, magnetic field is 0.3 Tesla. Then solving it, putting all these values and solving, you will get value of time period, you can get it putting all these values. Then pitch is equal to v cos theta into time period, or directly using the formula, pitch is equal to 2 pi mv cos theta divided by q, and all the data are given. Mass of proton, speed 4 into 10 to the power 5, cos 30 degree, cos 30 you know, root 3 by 2, and charge of proton, V is magnetic field 0.3, and putting all these values you will get pitch is equal to 4.35 into 10 to the power minus 2 meter. You can solve it easily. You are intelligent, you are talented. Okay. Next question. Question number 2. Question number 2 again easier question. A charge particle of charge Q and mass M. Charge particle of charge Q and mass M enters in a magnetic field B I cap. See, magnitude of magnetic field is B, direction is along positive x-axis, means B I cap. Okay, with a velocity V is equal to V1 I cap plus V2 J cap. See, this is direction of magnetic field B I cap along positive x-axis, and this is direction of velocity V. This is direction of velocity V, which is equals to V1 I cap plus V2 J cap means component of velocity along the direction of magnetic field is V1. Direction is along positive x-axis V1 I cap, and V2 J cap is directed along y-axis. So due to this velocity, the charge particle will experience no force and will tend to move in a straight line. Any problem? Are you understanding? Okay. Due to this velocity, the charge particle will experience no force and will tend to move in a straight line, and due to this velocity, it will move in a circle. Means again the motion is helical. Okay. So this is given. This is the conceptual discussion, and we have to find what is the nature of trajectory. Suppose it is asked what is nature of trajectory here. The combined motion in a straight line as well as circular. So nature of trajectory obviously helical. And also it may be asked find radius of circular orbit. And radius of circular orbit is mv sin theta. In place of v sin theta here we have v2, which is responsible for rotation, mv2 divided by mv by qb. In place of v we were taking v sin theta, but here it is v2, mv2 divided by mv2 divided by qb. mv2 divided by qb. And time period, it may be asked to find time period. Time period is nothing will happen, 2 pi m by qb. There will be no change in time period. And if it is asked to calculate pitch is equal to v cos theta. In place of v cos theta we have v1 into time t. So this implies pitch is equal to v1 into 2 pi m by q. This is easier numericals and board based numericals. Okay. In next lecture we will have a small discussion on helical motion, means application of helical motion. Okay. Aurora boreal and magnetic bottle, very good concepts. We will have a small discussion on this part. Thank you, my dear children. Thanks.